Okay, let's get the WebAssign. So here's the class. Here's some chemistry. Let's look at that. Okay, first thing in this assignment, make sure to read all of this, all of these statements. These are things that you should know. Uh, I'm going to talk about the carboxyl group, the amino group, the hydroxyl group, the amine group or the amino group. Talk about how certain bonds are polar because they share electrons unequally. So let's look at a structure. So this question asks to click on the nitrogen of the amino group. So this is an amino acid. It has an amino group. This is an N with 3 hydrogens. This is a carboxyl group, C double bond OH. Amino acids then have variation in what's attached to the central carbon right here. So this is hydrogen, this is carbon. So this is a chain of carbon and hydrogen, which makes it nonpolar. So it's hydrophobic, it's water fearing. It will not dissolve in water. This end of the molecule, because the oxygen and nitrogen are more electronegative, meaning that they attract electrons away from the carbons here and the carbons here, and the nitrogen, I'm sorry, and the hydrogens. This part of the molecule is hydrophilic, and these bonds are polar bonds, meaning the electrons are shared unequally. So if we look at this amino acid, we can now move it around. So you can see the amine group, the carboxyl group, and the chain of uh, carbon and hydrogen. So amino acids are essential. We get them from our diet. We have to eat amino acids produced by plants. So again, we have the characteristics of this amino acid because you have a central carbon, you have an amine group, you have a carboxyl group. Carboxyl group is C double bond OH. The H here has moved to this nitrogen here, but this is your basic structure of an amino acid. So you have a central carbon, you have the carboxyl group, you have the amine group or amino group. They both are used interchangeably. This is the hydrophobic portion of this particular amino acids. Other amino acids may have uh, different groups attached here. So this is carbon and hydrogen. So carbon and hydrogen makes up a waxy, oily type of properties of this molecule. So this is hydrophilic, this is hydrophobic, this is the carboxyl group, this is the amino group. And when you have a carboxyl group, which is slightly acid, and the amino group, which is slightly basic, you have joined to the same carbon, and then you have attachments with this bond here, this covalent bond. All of these solid lines represent a covalent bond. These are nonpolar covalent bonds. These are polar because the electrons are shared unequally in this covalent bond because the oxygen is electronegative and tends to attract electrons away from this carbon. This nitrogen attracts electrons away from this carbon and away from these hydrogens. So that's an amino acid. The other stuff is stuff that I talked about in the PowerPoint. There's some new terms introduced. Okay, so hopefully that's helpful. Then we're going to go look at another assignment. So here we'll look at, we got that, biomolecules, see what we got there. Okay. Now we're going to have a discussion of fatty acids. So a fatty acid is a carboxyl group attached to a long chain of carbon and hydrogen. You have to click on a single bond connecting the carboxyl group to the hydrocarbon chain. So this is the carboxyl group again. The double bond is not shown, but anytime you see carbon, oxygen, and hydrogen, and another oxygen, that's the carboxyl group. This is called a fatty acid because this is an acid group. The carboxyl group can lose this H and donate a hydrogen ion to the solution. So it's called a fatty acid because it has this acid portion where electronegative oxygen has the electrons attracted to itself, so the electrons are shared unequally. All of these other carbon bonds or carbon hydrogen bonds share electrons equally. So here's another example of a hydrophobic chain, meaning that it's water-fearing, and this is how oils, waxes are built up. This is how gasoline is built. Gasoline is a liquid hydrocarbon. Okay, we can look here. Here's linoleic acid. This is another fatty acid with the carboxyl group. And because of unsaturation, you're seeing that the shapes of these fatty acids here, these hydrocarbon chains, can vary. If notice here, there's only one hydrogen per carbon. That means that this is a double bond. So the shape of these fatty acid chains can vary based upon whether the fatty acid, the hydrocarbon portion, has double bonds, meaning that it's unsaturated. And there's been tremendous discussion in the last many years of how unsaturation reduces calories of fatty acids. Okay, we have another person coming in. It looks like. Okay, Lauren DeWalt. Okay. So so we recorded that. I'll do it again. So we'll go ahead and record, stop recording, and go back and repeat what we just talked about. Stop recording. Stop recording.